On to the corr method, which stands for correlation. We're going to use our stocks data set here. So the way this works is if you call it without any parameters here, it will take the correlation between every pair of columns. So it's going to find the correlation between Microsoft and Apple, Microsoft and Schlumberger, Microsoft and Amazon, and so forth. And then all the other ones, Apple and Schlumberger, Apple and Amazon, and so forth. So what is returned is pretty interesting. You're going to get a square data frame. And if you have a lot of decimals over here, one thing you can do is we can just round this off so it just makes it nice and neat. So the columns will also appear in the index. And what you see here is the correlation in stock prices between every pair of stocks in this data frame. You're going to get a square data frame. That means the same number of rows as columns, and symmetric. So that means a symmetric data frame means you have the same value on one side as you do on the other. You have the diagonal will be the same. Over here it is 1. So you can see here that the row, this column, excuse me, is the same as this row. So this Microsoft row is the same as this Microsoft column. This Apple row is the same as this Apple column. So that is a symmetric data frame. So what it produces is the correlation between two variables, which is a measure for determining a linear relationship between two variables. Specifically, it calculates the Pearson correlation coefficient. So it is a number that represents the amount of change that if when Microsoft say goes up $1, how much can you expect Apple to go up? So you can see that they're very highly correlated. The numbers range between -1 and 1. So 1 is a perfect correlation. Every stock has a 1 correlation with itself, right? So that makes sense. If there is a negative correlation, that would imply that an increase in one stock corresponds to a decrease in the other stock. So we actually do have some negative correlation over here. So between Facebook and Schlumberger. So when Facebook goes up, Schlumberger goes down, and vice versa. When Schlumberger goes down, when Schlumberger goes up, Facebook goes down. Same actually relationship with Visa, but it is not as strong over here. So one thing that you'll notice is that the tech stocks, so Microsoft, Apple, Amazon, and Facebook with highly correlated with one another. You can see over here, actually Amazon and Microsoft are particularly very highly correlated with each other. And then I have some energy companies. So Schlumberger is an oil and gas company, Exxon Mobil. So they have less correlation with Microsoft. But if you look over here, Schlumberger and Exxon Mobil are highly correlated with one another as well. So pretty cool. A method over here to do correlation of every column with every other column that you have. So you do have if you know about other correlations, Pandas does give you different options. Kendall or Spearman's correlation can work as well as your own. You can actually produce a custom correlation there as well. Okay, so that is how you use the corr method in Pandas.